Let's go through angles 1 and 3. What relationship or what category would those angles fall into? Angles 1 and 3 are they're on the same side of the transversal, one in the interior, one in the exterior. These are corresponding angles. So let's see what happens if corresponding angles are equal. Is there enough information to show that lines are parallel if that's the case? Okay. So we have angles 1 and 2, or angles 1 and 3 in our proof. Okay. We can either try to show that same side interior angles are supplementary, or we can show that alternate interior angles are equal. Okay. Either of those can be done. Let's start with the alternate interior angles. Okay, so looking at this, the only interior angle that we have introduced in our proof right now is angle 3. What's the alternate interior angle pair for 3? 7. So is there a way that we can show that 3 and 7 are equal? Well, we don't have 7 introduced into our proof, so let's introduce that. Can we introduce angle 7 in terms of the angles that are already in our proof? What do we know about angles 1 and 7? They are equal because of vertical angles are equal. Okay, so now we've introduced angle 7. So is there a way to relate angles 3 and 7? Well, yeah, here we have two things, angle 3 and 7, that are equal to the same thing, angle 1. If two things are equal to the same thing, they are equal to each other. So angle 3 and angle 7 have to be equal. That is an illustration of transitive property or substitution. And again, once we have 3 and 7 equal, what do we now know about the lines? Lines have to be parallel due to alternate interior angles. Okay. So we can now kind of build this up. We have a new theorem. Our new theorem was angles 1 and 3, which are corresponding angles. So if corresponding angles are equal, then that's enough to show that lines are parallel. Once again, we have our conditional statement and our conclusion in our theorem, and we can again abbreviate this. Corresponding angles can be abbreviated CA.